This is Lecky Stein. Creality recently reached out and they offered up their prosumer level 3D scanner. Something that definitely feels like it was developed for users like me. The amount of power and potential that is packed inside this box at this price point, it's actually got me really excited. I'm always on the lookout for ways to simplify the process of capturing really complex geometry for my project complex. So the real question is, can this tool answer that call? Disclaimer though, Creality did send me this scanner free of charge, but we have an understanding that I would only create a video under no obligation to publish anything at all if it doesn't meet my expectations. So everything you hear in this video is 100% my own opinion. With that out of the way, let's get this Raptor Pro unboxed. I found the rustiest knife that I own. Try not to damage the box. Wow, this is actually a really heavy-duty Pelican case. USB adapter. We got some lens cloths. A lot of markers. And these would be your different varieties of AC power outlets. So I'll be using this one because I'm in Canada. AC power supply. This one is 12 volts at 2 amps. And it's just using a standard barrel connector. USB cable, judging by the number of pins in here, it's definitely USB 3. And there we go. That's a USB-C. So USB-C plugs into the unit itself. This would plug into our computer. We supply it with its own power using. There is more underneath. This would be the calibration panel. It looks like it's maybe glass. Save the best for last. And there it is. Well, it's got some real weight to it. The one thing that I've found with other 3D scanners that I've used, which have all just been kind of hobby scanners, but they're always so small and so light that when you're going around and you're scanning, the little movements in your hand get super amplified because there's no mass. And this one here has got some real good weight to it. And I really like the positioning of these buttons. Oh, also these little rubber spots on the sides. You can set this down while you make adjustments to whatever you're scanning. And you're not scuffing up the painted surfaces here. So I like that little detail. Connector would plug into the bottom here. Let's see how rigid this cable is. Well, first off, it's not very long. So wherever you're going to be scanning, you're going to have to do it 6 feet from your computer. Now this style of cable, where they have 2 cables side by side, they tend to want to be able to bend really nicely in one direction. But if we try to bend it in the other direction, it really puts up quite a lot of resistance. And this might influence how you scan. Whether that actually happens in practice, we'll find out. Now, I'm going to be spending the next few days to get to know the scanner. And I would like to share my initial experience with you all and a little bit about how it all works. But before I get to that, I want to talk about the wild claims of this machine because this thing's actually got 3 laser emitters and it works with 2 different modes. There's a 22 cross-line laser mode for fast, high-accuracy captures, but there's also a 7 parallel line mode that'll give you that really extreme precision. And how precise is it? Well, it's rated give or take 0.02 millimeters to 0.08 millimeters of drift per meter. Translation? It is ridiculously precise. So even if you're scanning something bigger than, let's say, your workbench, this thing is able to track like it's nobody's business. Whether it's a tiny bolt or you're scanning an entire motorcycle frame, guys, it's game on. Drift won't be an issue. But what about shiny black plastic or bare metal? Well, according to Creality, sprays are not needed, which sounds awesome because not only is infrared spray really expensive, honestly, it is a pain to work with. Longer scans when it starts fading away halfway through the job, yeah, been there too many times. Now the Raptor Pro can pull in 660,000 points per second and up to 60 frames per second. So in laser mode, maybe my gripes with infrared sprays disappearing too quickly will be completely irrelevant. But beyond the laser mode though, the Raptor Pro also supports the NIR, which is near infrared mode. And this is a more traditional method of scanning, which most hobby level scanners are using still. This mode still keeps up with a 30 frames per second, and it can deliver a full 24-bit color scan. Now, I will be focusing mostly on the laser technology myself, since my own use case will greatly benefit from rapid scanning with high dimensional accuracy. My bottom line though, to prototype something or I'm pixel hunting for that perfect mesh, I think the Raptor Pro can really address any workflow that I throw at it. But enough talk, I want to put it to the test. It's been a few days since I've started using this tool, and it is safe to say I'm hooked. Now, you don't have to be an engineering type to start using the Raptor series scanners, and here's actually a really good example of that. Let's make a custom tray for a storage solution that hugs every contour of this remote. And that's actually been really challenging with other hobby grade scanners that I've used in the past, which by the way, were not cheap scanners by any means, and actually well within the Raptor price territory. So how does the Raptor Pro compare to some of these other scanners that I've used? Well, this Edge remote actually serves as a sort of torture test for 3D scanners. Here we have some white plastic, there's some shiny black plastic. The buttons are actually clear and they have some print below the surface. The trackpad is black and it has somewhat of a glossy finish, and there's lots of places for the light to just get lost in the cracks. To top it all off, this is actually a really challenging shape just to try to take multiple scans and combine them together without putting stickers all over it. The only way that I've had good success in scanning this object with other scanners was to actually just use a lot of this IR spray, which is challenging in itself because it disappears so fast, so you're constantly applying it. I also had to put a lot of stickers on this, and then just sheer patience. So let's dive into Creality Scan. We'll set up the scanner, we'll calibrate it, then we'll dive into the nuts and bolts of the software, and we'll just have a look at how we're going to tackle such a task. On my computer here, I've got Creality Scan set up. It's showing that the scanner is undetected right now, so when we plug our scanner in, you'll see how quick it detects it. And it's usually within about 3 or 4 seconds, and there we go. So it's now connected to the scanner. Up in the right-hand corner, there is a calibrate button. So if we go down to the bottom where it says Start Calibration, we can scan this QR code. There we go. And we're going to try to line up the markers so that they're all staying in the center. And we're also going to position the scanner so that we're projecting it to the center of the plate. Once you've kind of oriented that, then you're going to slowly raise the scanner up. And to be honest, I am terrible at this. I've done this quite a few times and I still am struggling to do it right. Okay, so there's one. Now it wants us to position the scanner off to the side. This side. All right. Now, this has been really challenging. I've done this quite a few times, and I still haven't quite got the hang of it. But we can see that I have a score of 97.6, which is actually the highest score that I've gotten so far. I'm not sure what kind of wizard you'd have to be able to move this thing in a perfect line at the perfect angle while keeping everything perfectly level or tilted, depending on the scan, but I am not that wizard. Now we'll go back to the Home tab. We're going to call this project Remote. Now we have some options here. So we have real-time resolution. This is effectively the resolution of the scanner. I'm going to bring this slider all the way down, so we're at 0.1, and this will be the best possible resolution. We have color mapping, and we're going to leave that set to off. The project that I have, I just want to capture really high resolution geometry. And then disable flat base. I actually have not had any luck with this. I imagine it is a feature that's on its way. So I'm going to leave that set to off. Now if I click scan, it'll bring up a pane here, and this pane will have a card, which is actually the viewport for the scanner on the left side. The exposure will be the sensitivity of the sensor. So it's similar to cranking up the ISO on your camera. The brightness is the physical brightness of the laser itself. If I crank the brightness up, you will actually see the laser intensity increase. There is a point cloud mode and there is a global marker. When it comes to global markers, there's actually a lot to understand and a lot to unpack to use them effectively. So what is a global marker? Well, a global marker is a lot like an anchor point for the scanner software. It helps the software understand where everything is in 3D space in respect to the object you're scanning. By placing these markers around the object, the scanner can then track the position more reliably and then stitch that model information together using known positions in 3D space. And it can do this all throughout even longer scans where you're stopping to apply this, or even really complex scans. Global markers are a lot like, let's say, landmarks when you're traveling. You might not always know exactly where you are, but if you spot a landmark, you can figure it out pretty quickly if you're using a map. The scanner software uses these known positions to calculate an absolute position of the scanner itself in 3D space. But what if you don't want to use markers? What if you just want to scan your object? Well, there's a few criteria that you're going to have to meet to be able to do that. Because larger scans, or scans that don't have a lot of feature details, or scans like this one where there's a lot of symmetry, the scanner tends to get lost and it can't remember where it last left off. So the best thing to do would be to place markers on the object itself. And then that would allow you to be able to scan, and the scanner will be able to find its place. Now, the only problem with that is you're going to have to remove these in post-processing. So what might be some good practices and things to keep an eye out for when you're getting set up? Well, the biggest thing for me, I think, is the visibility. You want to make sure that the markers are visible throughout the entire range of motion as you're scanning. And if there's going to be markers that you're placing off in the distance, usually with stickers, you want to make sure that you're using the larger markers. Otherwise, the camera is not going to be able to see them. One thing that I've noticed is really good with this scanner is its ability to lose tracking and then regain it immediately, and you almost don't even miss a beat. So the positioning of the markers, although is critical, once you lose that tracking, you'll be able to regain it very quickly, and you're not going to have any strange artifacts that I've seen in other scanning softwares I've used in the past. Besides global markers, another really important detail is actually your process and avoiding downstream issues. Have a look at this setup. Here we've got a turntable, we've got a plate. This plate actually has a bunch of markers on it already. It's rigid, which means that we can actually scan our global markers first, and then we can put our subject on top, and then we can rescan. This is not problematic and actually works really well. Now, there are two main things to consider with this setup. Well, we can scan mostly top down. We can capture the front face of this controller really, really well. But as we're trying to come down to the sides and scan the side profiles, we're going to lose a lot of our global markers on this side, meaning we're going to lose tracking and we're not going to be able to capture this geometry. The other thing to consider is, since most of the scanning is going to be top down, and we're going to have a really good impression of the top surfaces of this, it means we're going to have to flip this over and we're going to have to rescan the bottom side. And then in post-processing, we're going to have to try to put these two together. And the automation that is built into Creality Scan works incredibly well for this. But because these two pieces are so symmetrical, it doesn't know that they're different. And the feature detail isn't good enough to tell the difference apart. There's another approach that we can use though, and this approach would be to put a backdrop, and this allows us to capture a lot more range of motion. We're going to capture more of the side profile, we're going to capture the top, we're going to capture more of this side, and we can even start to angle just ever so slightly off to either side here before we lose tracking. And now we can flip this over, and then we can do the same, and we might just get just enough detail where we can put the two scans together, and Creality's built-in tools will be able to stitch it together and produce a single model. I've got my marker blanket set up. It's covering my table. I've got a nice backdrop. This should allow me to get a lot of range of motion here. I can come in at many different angles. Now, I can't get 360 degrees around, but we're going to take full advantage of the built-in tools that are in Creality Scan to allow us to stitch everything together afterwards. I have this box that I'm going to set down and put the controller on top, and this should allow me to get a good scan all the way around and make it easier to cut out the things that I don't want. Before I get this controller set up, I'm going to position this box maybe a little bit out further to here, and I'm going to capture my global markers. Using this approach allows me to scan in areas much easier to capture all of the markers that are available, and then I can put my subject on top. But what is really important to keep in mind is that I cannot disrupt anything in my scene. Because this material is very flexible, this allows an opportunity for me to kind of disrupt it, and that will throw the whole thing out. Now, when you finish your global marker scan, all you have to do is click Point Cloud, and then you'll get this pop-up that asks if you want to complete the scan, and we'll say yes. Now, from this point, it is very important that we do not disrupt our global markers. I will very carefully now set our remotes into place. We will need to select our scan mode. I'm going to aim for the more accurate option and go with the parallel lines. One last thing I'll do before I start scanning is actually turn these lights off. I'm not entirely sure if this will affect the performance, but I feel like it does play a small role. Okay, so it seems like my computer is really struggling to handle the task of recording the entire screen and running the software. So what I'm going to do is stop the screen recording and see if that helps. And that did actually help a lot. I jumped up about 5 frames per second. Now you can see here that just using the automatic settings for the brightness and the exposure, we're actually having a really hard time to try to capture all of the details. These buttons here are clear, but it seems like the print that is underneath the buttons is showing. The white portion of the remote is revealing very nicely, and even these black buttons here, which are kind of a matte black. So I'm actually surprised that these are showing up almost as well as the white. The trackpad, however, has a bit of a glossy finish, and it's just not registering at all. I will have to increase the exposure quite a bit more to capture that. The D-pad too also has the same issue as the other buttons. One thing that I'm going to cheat just a little bit with here is actually just removing these thumbsticks so that we're not casting a shadow. We're still within the scan, so if I were to click stop, this is going to process the scan, but if we want to abandon the scan, it's actually a little bit tricky. You go over here and you press new scan, and this will give me an option to exit without saving. We just say yes. And now we have the opportunity to make a new scan. Now it does seem like we're able to capture this trackpad a lot better this time around, and I've got the exposure and the brightness cranked almost all the way up. You can see that the exposure and the brightness are pretty well maxed out. We were able to finally capture the trackpad, and it actually looks fairly decent. I need to get a little bit more detail in a few areas. For the buttons, we're still really struggling to get a good capture of this acrylic. And on the other side, these buttons turned out just a little bit better, but not really by much. We're still missing a lot of information around the radius. And by the way, when things are orange, that means that they still need some attention, and if they're green, there's enough points there. So the more green this model is, the better. I got the remote nicely coated with IR spray, and we'll give this a try. I think what I'll do is set this back to auto and just let Creality figure out what it wants for exposure, and we'll see how it works with the IR spray. And this is scanning really, really nice. Wow. All right, now this is a world of difference. Using the IR spray is obviously going to be the best option if you want to get the most information. Let's process this and see where we're at. What we do is we just cut away whatever we don't want just by drawing around it like so. We try not to intersect with anything that we want. And you select the inverse down here at the bottom. Let's make sure that there's no red touching anything that I want to keep. And then at the bottom, there's a little trash can. You just hit that. These spots here where I couldn't quite get all the way to the front to scan, I'll just remove them because this will just create a lot of noise. So we'll just go like this. Now these little spots here where we have some holes, I'm just going to remove everything inside this hole because again, this will just be noise. If we go over to the right side toolbar, there is an optimization setting. This is what we want next. I know a lot of people are going to be really tempted just to press the one click, but we want to have a little bit more control over what we're doing. So if you hover over this, it'll bring up this pane. Do not click this. It's a little bit funny, but if you click it, it is going to process, and we don't want to process just yet. So let's turn on Ultra Detail. I'm going to bring this all the way down to the setting that we use, which is 0.1. And it won't go any lower than 0.1 because we're not going to get any additional information because our point cloud is already 0.1. So all we're going to do is just add little divisions in between each of those point clouds, and that will just make our file a lot bigger than it needs to be. For the sensitivity, I'm just going to leave this at 0.5. I played around with it a little bit and I actually haven't found it to have any effect on my model. And now if we go back over here, if we click, we're actually going to start processing. The processing has finished, and now we can kind of look at it a little bit and check out the point cloud. We can see it did a really, really good job. There's only a few tiny little spots where it didn't get, like in this little crack here. Even inside this little area, wow, the detail is incredible. It's only been about 10 minutes and some of the spray is already starting to wear off of the button, so I'll just dust this up just a little bit and then we'll continue on with the other side. So this is our second scan here. I've got it all cleaned up. And you'll notice that every time I do a scan, I come through and I clean everything up. And the reason for that is because that information is just going to eat up all of my RAM. I'm going to end up just running out of RAM and I won't be able to start a new scan. Now I'm going to turn this over to the back side. I'll get this sprayed up, we'll scan it in, and then we'll see if we can put these pieces together. Now, to try to scan inside these little holes, there's actually one thing that we can try to do. If we go here to local detail, and for the resolution, if I hover over it, you'll notice that it seems to be locked to 0.05. I don't really have an option. So we'll just leave it at that. And now if we zoom in, we can highlight the areas that we would like to replace with a higher amount of detail. By holding Shift and left mouse button, I can kind of draw out the area that I would like to replace. Okay, so there's one here, and I'd like to grab this one too. And now I get a pop-up that says that everything that is in these areas is just going to be deleted. That way we can replace it. So I'll say yes. Where I want the additional detail, I'm going to very carefully spray some IR spray. And the other thing that's important is you don't press the button in this case. You just start scanning. Because if you press the button, it's actually going to stop the scan and it's going to go to the next phase. Okay, I think I got enough of this local detail. I'm not sure if it even did much, but we'll see. Now the area that had the local detail was supposed to be just these little circles right here, but for whatever reason you can see that it applied all of this additional information in this entire area. I'm not really sure I understand how that works, but I can get resituated. Now let's check out our scans. So on this left panel here, we have the 4 scans that we took. This one here, we didn't process the point cloud data, and that was when we are using this tool here, optimization setting. So I'll go ahead and do that now. All right, so there's a small little artifact here. I will remove that. All of our scans now are ready to be meshed up. So if you go over here to this little puzzle piece and you click that, this will bring you into the merge section. There's 2 ways that you can merge things. We're going to be using the feature merging, and this will look at all of the features of our scans and try to match things up so that they fit like a puzzle piece. The other option is to use markers to link things together, but you would have to make sure that there's markers on your scan. And then there's manual merging. So this lets you take 2 components and then manually pick the areas that you want to link together. But we're going to go back to auto merge and we're going to use the feature merging and hope for the best. And look at that. That is incredible. There is absolutely no doubt that with the right approach, the Raptor Pro can get incredibly high quality scans. But now the question is, how do you get this model out of Creality Scan and into something like Fusion 360 so that we can make a tray like this, and we can use that geometry to cut away the surface? Up on the left-hand side, the point cloud from our scanned data is turned on. On the right-hand panel, we've already gone through the optimization for the point cloud. We've merged our parts together, and now we're ready to mesh, and then we're going to export. So the mesh settings, like before, you just hover over this, you don't click on it. We're going to leave this on the manual setting. We're going to set the face count. The way I see it is if there's 3 points to make a triangle, your total number of points in the point cloud, we'll just divide that by 3. So our point cloud is nearly 12 million. Close enough. For smoothing, this actually has 4 settings. I found 2 seems to work pretty good. I'm going to leave hole filling off, but I'm going to turn on closure. So this would automatically fill any holes. And now we can click start. And we're back with the final model. And this is just looking so good. This is super clean. Let's export this. We'll export as an OBJ for the next step. For the next step, we need to manipulate that model just a little bit to clean up some of this geometry that we don't need. Like we don't need these holes, so we have to fill them all in, and we have to fill in this little groove here because we don't want any of that stuff to be 3D printed in this model. To do that, I'm going to use Autodesk Meshmixer, and this is a free software. It's really easy to use. You can use other things like Blender, but this one would be good for this demo. So we'll just import our model. We'll go into the Sculpt tool. We'll look at the brushes, and Robust Smooth might be a good starting point. Now all you have to do is just brush away. All right, so this is looking pretty good. We're going to move on to the next step. I even smoothed out just around the buttons, and that should help with the fitment. Now we can export this. In order for Fusion 360 to turn this into a solid, we need to change the mesh topology. We're going to turn it from a triangle mesh into a quad mesh. And we're going to use a tool called Instant Meshes. It is another free piece of software. After you open your mesh, we're going to remesh it as quads. I usually leave most of this stuff alone. I just hit solve. And now we can have a look at the flow. And this will make more sense in a moment. But you can see how some of these lines kind of overlap this seam. So we're going to grab the comb tool and we're just going to draw a couple lines here. And if we come down to the position field and we solve this, and now you can kind of see what it did. So you'll want to go through and you want to try to clean this mesh up so that it makes the most sense. So you're going to want to go through and just try to draw some lines around any of the edges the best you can. And you don't have to spend too much time, but this will really help with getting a really good mesh out of this. And now we can solve for the position field, and you can see that this is looking really good. So next we're going to export the mesh. I select Pure Quad Mesh. Smoothing iterations, I set this to 2, and then you click Extract Mesh. And this is what the mesh will look like when it comes out and goes over to Fusion 360. And now the final step. We're going to use a design plugin from Fusion 360, and we're going to turn this mesh into a solid. Now inside Fusion 360, we are in the mesh environment, and we went to insert a mesh, and here's our mesh. And we just have to position the triad so that it looks like it's lined up to our model, and every time you make a move, you can hit move to ground. After you click OK, now you can see this mesh and the work that Instant Meshes did, and it did such a nice job to remesh this model. We're going to click bodies, and we can see our mesh here. And if there's any problems with the mesh, you'll get a little exclamation mark beside it. To turn this mesh into a solid, we're going to click modify, convert mesh, and then click the body, and then we're going to click base feature, and then it's this cylinder on the end. For whatever reason, they don't label them with this plugin. The resolution is going to be this one here, and then for the accuracy, I found this one works really well, and then process holes, we'll leave that off, and then we click OK. The conversion process is now done. And it takes about 15 minutes, but you can see that this automated tool has done a really good job. Even with some of the noise that was in this little crack here, it cleaned up a lot of this stuff. And now if we look at the browser, we can see that the mesh has now been converted into a solid. I'll throw an appearance on here and render it and see what it looks like. This render is looking really good. Now we'll use the solid body to cut this impression. We'll just move this up just a little bit, and we'll go down to the side. We'll just move this into it ever so slightly. And now that the controller is in the position that we want, we go to Combine. Target body will be the bin. The tool body will be the controller. The operation will be cut. And then say OK. And now we've got the perfect impression of this remote in the tray, but it is the exact size. So what we can do is we can click on a surface here, say offset face, and we'll make the surface just a little bit bigger by maybe -0.2. And that should give us a little bit of room for the controller to fit nicely. And then the last thing we can do is just to throw a fillet on this edge. We'll just go 1 millimeter. Now from this point, we can click Bodies, we can right click, save as mesh, and we can export this as an STL and send it right to our 3D printer. So after all of that, what is the good and what is the bad when it comes to the Raptor Pro? Well, first we'll start with the good. Hands down, this has been the best scanning experience that I've had to date. The setup, the software, and the final result, it just works. And while having a good basic understanding of 3D scanning concepts can definitely be an advantage, but it's not a necessity. The learning curve on this tool is actually remarkably flat, and I'm confident even first-time users coming into this tool will find it very approachable and very intuitive. The entry point for the Raptor line actually starts at a very reasonable $14.99, and the Pro version that I tested here is $19.99 on the Creality website. So considering what you get, that's actually a pretty compelling price. The Raptor Pro delivered really high accuracy, clean scans, and that's exactly what I expected. But where I was also surprised was to find that this was incredibly responsive. I could move it around, and as long as I captured the global markers nicely, I can move this all over the place, and honestly, you cannot make it lose tracking. I tried. It just can't be done. All right, now the not so good. And it's kind of a short list, and it might even be as short as the provided cable. If there was only one thing that I could change about this product, it would be the cable. Not only is it on the short side, but there's also a lot hanging out of your computer, so when you're scanning, you're not really paying attention to how much cable you have. And there's been a few times where I've kind of tugged on it a little bit, and then I go back and check, and I've actually found that I put a small bend in the adapter, and it doesn't take much stress to break this off or to potentially cause damage to your computer. So I would like to see a better cable solution in the future. And while the Raptor Pro can actually handle a variety of surface finishes really well, it does struggle when multiple surface types are present in the same scan, like we had with this remote, where we had some dark, we had some light, we had some reflective, we had some matte. You might need to just play around with the exposure settings, and in some cases you might even need to scan it in multiple passes with different exposures. And then you'll have to go back and stitch everything together. So realistically, as much as I love not using this spray, this is probably one of those times where using the IR spray would actually make life so much easier. And finally, this isn't really an issue with Creality or the scanner, but it's something that I haven't seen in any consumer level software yet. There's no way to define a coordinate system when exporting. I'd love to see a feature where it lets you pick, let's say, 3 points to define a plane, and that should be enough to just at least lock in the roll and the yaw and the tilt. That way, when you're exporting, you're not having to fiddle around in the CAD to set up these orientations later on. I hope that you learned something from this video, and I want to give a big thank you to Creality for sending out this Raptor Pro. I had so much fun learning this tool, and I really appreciate the opportunity, and honestly, I cannot wait to start using it in my own projects. If you're interested in learning more about this Raptor Pro or other Creality products, I put some links in the description below. As always, thank you so much for watching, and I will see you on the next one.